This is video 63, finding the area of parallelograms and trapezoids. Let's start by defining some vocabulary. The base of a parallelogram. A parallelogram can be a square, a rectangle, or a parallelogram. Parallelograms are defined by two sets of parallel sides, here and here, and here and here. Now it's important to know what the base of a parallelogram is. This could be the base, or this could be the base, or this, and the same on all of them. Any of them could be the base. What's important is once you define the base is how you go about defining the height of your parallelogram. The height is always perpendicular to the distance between the sides whose length is the base of the opposite side. So for instance, on this shape, if I decide this is my base, I need to find what's perpendicular from here to here. That would be my height. If this were my base, let's undo this. If this were my base, then my height would be here. And again, it needs to be perpendicular to my base. Now, the base of a trapezoid is a little bit different. A trapezoid only has one set of parallel lines, here and here. So its height would have to be perpendicular to its bases, which would be this. Again, it's perpendicular. So for each of these, they form a right angle to their base. Now, there are two formulas that we're going to talk about in this video. One is the area of a parallelogram. We're talking about a square, a rectangle, or a parallelogram. And that's area equals base times height. We just defined what base and height are. Now the area of a trapezoid is a little bit different. If I have a trapezoid, it actually has two bases, base 1 and base 2, and then its height, again, is perpendicular to its bases. So this would be its height. Here's the formula. There's actually two ways to write it. Oops. Now I like to use this one mainly because it's easier to deal with a half than it is to divide by 2 when there are variables involved. So let's think about the formula for the area of a trapezoid. If I have a trapezoid and I have base 1 and base 2 and its height, and I flip my trapezoid over and make a copy of it, I now have base 1 here, base 2 here, and again the height. So if I take base 1 and base 2 and add it, I have what would be the base of a parallelogram, kind of like this one. Alright? If I multiply the height by that, then I find the area of this entire shape. Alright? But we really only want to know what one of the trapezoids are, so we divide it by 2. So it's base 1 plus base 2 times the height divided by 2. Now let's practice using some of these formulas. We want to find the area of this parallelogram. Again, we know the base is 7.5. We know the height is 2. Well, if we're going to use the formula base times height equals area, then we would multiply 7.5 times 2. And this would give us area equals 15 centimeters. And remember, it's squared because we're multiplying. So we're talking about little square centimeters. How many little square centimeters would fit inside that shape? And it comes out to 15 centimeters squared. This shouldn't be new to you. Alright, now let's find the area of a trapezoid. Again, let's go back to the formula. It's 1/2 of base 1 plus base 2 times its height should give us the area. Now you just need to plug in your formulas. Here's base 1, base 2, and our height. So 1/2 of 9.3 plus 7.1 times our height, which is 7.5, gives us our area. Alright? Well, order of operations tells us that we have to do this addition first. So 1/2 times 16.4 times 7.5. If we multiply these out, we'll get 61.5 feet. And again, it's squared because we're talking about feet squared. Alright, here's another one. Again, we're going to use the formula area equals 1/2 of base 1 plus base 2 times the height. So area equals 1/2 times base 1 is 9 plus base 2, which is 7, times the height, which is 1.8. Well, 9 plus 7 equals 16 times 1.8 times 1/2. This should give us our area. And our answer should be 14.4 equals area, or 14.4 millimeters squared is the area of that trapezoid. Now, find the unknown measure of the parallelogram or trapezoid. Well, this one's a parallelogram. Now, we're only talking about the shaded region. We know the area, okay? But we don't know the base. We know the height. We know that base times height gives us our area, so 36.18 equals 5.4 times our base. Alright, using our transformation principles, we can divide both sides by 5.4. And that should give us 6.7 millimeters. Again, this is not squared because it's the length of our base. So our base equals 6.7 millimeters. Here's another one. Again, we know the area. Now we know the height. 294 equals our height times our base. Again, you're going to have to use the transformation principle of division for equality. If I divide both of these sides by 14.7, it'll leave me with B, which means B equals 20 feet. So my base is 20 feet. Now let's apply this. Let's say we have a set of coordinates. Let's start by plotting our coordinates. Well, our first coordinate is -5, which is on the x-axis, and I go up 4, and I have a point here. -3 up 2, I have a point here. -3 down 4 here, and -5 down 4 here. So now I have a rectangle, or actually a trapezoid, that looks like this. Again, it's a trapezoid because it only has two parallel sides. So we're going to start by saying this is a trapezoid. Okay, now I need to find the area. So I'm going to take 1/2 of base 1 plus base 2 times the height. Alright, I need to figure out what my base 1 is. This is base 1, this is base 2, and this would be my height. To find my base 1, I'm going to take the measure 4 here, and I'm going to subtract from it -4 here, because that's the distance from this point to this point on the y-axis. Well, if I add the opposite, this gives me 8. So base 1 equals 8. Alright, here I'm going to go from 2 to -4. So if I find the difference between those two, again, add my opposite, that tells me that base 2 equals 6 units. Alright, my height goes on my x-axis. That goes from -5 to -3. So -5 minus -3, if I add my opposite, I get -2, but it's the absolute value of that. So my height equals 2. Now I have the information I need to solve the problem. Area equals 1/2, base 1 was 8, plus base 2, which was 6, times the height, which was 2. Alright, these two are reciprocals, so they're going to become 1. So my area equals 8 plus 6 times 1, or my area equals 14 in units squared. Alright, let's do one more problem. Now this shape's unusual. It's not a trapezoid or a parallelogram. So we need to divide it up. Let's cross it here. Right? Now what dimensions do we need to know? Well, this one's easy. Our base is 35 and our height is 9. And because it's a rectangle or a parallelogram, we're going to use base times height equals area, or 35 times 9 equals 315 inches squared. So this is 315 inches squared, the area of that shape. Now, this one's a little more complicated because we need to know the height and we need to know this base. Well, we know that the entire distance across is 35 and this is 15. So if I take 35 minus 15, that means that this part is 20. Alright? My height is going to be 20, which is the height of this side, minus 9, which gives me 11. So I have a height of 11. So now I can take my 1/2 base 1 plus base 2 times my height and get the area of the trapezoid that sits on top of my parallelogram. Alright, so 1/2 times 20 plus 18 times 11 should give me my area. Alright, 1/2 times 38 times 11, or 19 times 11, gives me 209 inches squared. I need to add these two together. This is 219 inches squared. If I add those two together, I get 524 inches squared, and that is the area of the entire figure. This is the end of the video number 63 on the areas of parallelograms and trapezoids.